Men om du kör 3 då kan jag
Okay, good afternoon. So, as I told you, I want to go to the next chapter and then combine the topic of two chapters in one exam. Okay? And this chapter is actually very important. Probably this is totally new for you. It doesn't necessarily mean it is hard, but I mean this is completely new. Today we want to talk about quadratic equations. So, if you remember, we have already talked, even from your school days, you've learned about how to solve first degree equations. By first degree equation, I mean an equation in which your unknown, the exponent of your unknown is at most 1. It's exactly 1 actually. Yes. So for example, you are now very comfortable, hopefully, with solving such an equation. This equation is a first degree equation, yes, because you see the unknown appears with power 1, with exponent 1. That's a first degree equation, and you already know how to solve that. When you want to solve a first degree equation, you try to make your variable alone on the left hand side, and then that whatever is on the right hand side is your answer. For example, in this case, you would write 2x and move minus 4 to the right, and then to make x alone, you have to divide everything by 2, so then x becomes 2, that's your answer. But having x alone on one side and the rest on the other side is only for first degree equations. From now on, if we increase the degree, usually this does not work. First of all, for example, if I write 2x squared minus 4 equals to 0, yes, that is a second degree analog of this equation. Yes, this is a quadratic equation because the unknown gets power 2. Yes, for solving this one, exceptionally or coincidentally, you can do the same trick. Yes, for example, you can make x squared alone by dividing by 2. It becomes 2. But then, of course, I want to find x. I have to take a square roots. But then I have to put plus and minus. Do you remember? Because there are two numbers whose square is 2. One of them is the square root of 2. The other one is negative square root of 2. Yes? But this is not usually the case. Because if I have the second degree equation, I might also have the first degree there. For example, what happens if I want to solve this equation? Yes. So in that case, this method does not work. How can I make x alone on one side? Yes. Even if for example, you might say that, okay, I move 4 to the other side, I divide everything by 2. Still, this is not x alone. It's a combination of x squared and x, which is left alone on the other side. So the solution will not be that easy then. Then we have to find a way to be able to solve this equation. Yes? Okay, so the topic of today's lesson is simple. We want to know if there is a general systematic way that we can solve all possible quadratic equations. Yes? We want to start knowing about that. So first of all, if I want to ask you what is the type of equations we will be facing, you will say that, okay, we will have an equation of this form. So in this chapter, for a while, we will be busy with solving this equation for all possible values of a, b, and c. Yes? So here, a, b, and c. You remember this symbol that I use means belongs to, and this means the set of real numbers. So this means that I want to consider this equation in the case that a, b, and c are real numbers, But of course, I think that you agree with me that I also have to add this constraint that a is not equal to 0. Why is that? Why I should consider that a is not equal to 0? Because if a is equal to 0, what will happen? This term will go away, and then what is left for me is a first degree equation, and I already know how to solve the first degree equation. So if I want to make a problem to make the problem interesting, I have to assume that a is not equal to 0. Otherwise, I will go back to the old problem, and I already know how to solve it. Yes? So in a second degree equation, this is the general form that I want to consider. For example, in this case, if I ask you what is playing the role of a in this equation, you would say in this equation, a is how much? Is 2. What is b in this case? So a is the coefficient of x squared. B is the coefficient of x. What is the coefficient of x here? 0. And what is the constant term? -4. That's the numbers here. Yes? In this equation that I considered, what is a? A is 2. The coefficient of x squared. The coefficient of x is called b, which is -2. And c, the constant term, is -4. Yes? I don't know, in some reason the Swedish books make it so complicated. So step by step, pages after pages explaining about this. That is not that hard, okay? So that we want to explain it so much. But of course, in some ways I also agree with them that we have to consider this problem gradually. The hardest part of this problem is the case that all a, b, and c are non-zero. If a, b, and c are all non-zero, then that would be the full problem, like this. If a, b, and c are non-zero, we need to find a way to solve it. But before that, I consider two special cases, and I want you to learn these special cases separately. One special case is the case where b is 0. Another special case is the case that c is 0. And then the case that a, b, and c are all non-zero. So we want to divide the problem into 3 subgroups, yes? The problems in which b is considered to be 0, the problems that c is 0, the problems that none of them is 0. Of course, if you learn the method for none of them equal to 0, you can use the same method for these two as well. But I would really prefer you to learn them separately. Okay, so let us understand this part first. What happens if b is 0? If b is 0, then the equation that I am facing is an equation of this type. And without any explanation, you actually know what to do. This is one of those problems. You see, b was 0, and I was able to solve it even without explanations. Yes. For example, what happens for this equation? Yes, I will have 4x squared minus 16 equals to 0. This is a quadratic equation. How should I know that? Because I see the power of 2 appears for x. And then I hope that you agree with me that in this problem a is 4, b is 0, and c is negative 16. For this problem, remember, if b is 0, more or less you use the same method, except the very last that you are taking the square roots. In that case, you have to remember to put plus and minus, yes? So what I want to do for solving this, I make x squared alone by moving 16 to the other side and then dividing everything by 4. And then this is the last part. If I ask you what is x, x is a square root of 4, but not only that one, you have to put plus and minus. But if I ask you what's square root of 4, The answer is simple, it's 2, and then I have a plus and minus here. So, what is the meaning of this symbol plus and minus? By the way, this is a short form of writing x is equal to minus 2 or x is equal to 2. Instead of writing x equals to minus 2 or x equals to 2, which is the correct way of writing, people write x is plus or minus 2. It doesn't mean and is meaningless, yes? X cannot be simultaneously equal to 2 and minus 2. So, but I will use this convention more or less all the time if I can. This means that I have two solutions. There are two numbers, plus 2 and minus 2, so that if I replace x with those numbers, this equality turns out to be right. Yes? So actually you were able to solve a quadratic equation in which b is 0. What do you think about this? For example, I have 3x squared plus 9 equals to 0. If I want to solve this, so what should I do? Here, it's a quadratic equation. Why? Because the power of x that appears is 2. And if I ask you what is the value of a, the value of a is the coefficient of x squared, which is 3. The value of b, which is the coefficient of x is absent here, so its coefficient is 0. And then the constant term c is positive 9. If I want to solve this, I have to do the same method. I want to make x squared alone. This becomes 3x squared is equal to minus 9. I make x squared alone by dividing by 3. Okay, then you have to be careful. So what is the rest? What should I say now? Yes?
No solution.
There are no solutions. Because regardless of the value of x, positive or negative even, when I square it, it becomes non-negative. So it cannot be equal to a negative number. So that is what you need to get used to. In first degree equations, we almost always have one solution. But in second degree equations, I gave you an example with two solutions, and I immediately gave you an answer with no solutions at all. So you need to get used to this. Is completely common when it comes to quadratic equations. Yes? So then it means that no solutions. This doesn't mean that this equation is wrong. It is meaningless to say an equation is wrong. You can either say an equation has a solution and these are the solutions, or you can say that an equation doesn't have any solutions. Yes? So be careful. You cannot say that an equation is wrong. So no solutions. Is that clear? So for the case that b is equal to 0, either you face this scenario or that scenario. Either you have two solutions or no solutions. Can you imagine a case for me that I have exactly one solution? So give me a quadratic equation for which b is equal to 0 and I have one solution. This is a special case actually. Yes?
If x is 0.
So what is the equation itself? So for example, as you said, if I write 3x squared is equal to 0, yes? This is a quadratic equation because you see a power of 2 for x, and b is equal to 0 because the coefficient of x is 0. But I want to solve it. I have to make x squared alone. I divide everything by 3, it becomes that. But x squared is 0. If you want, you can write plus or minus the square root of 0, but plus or minus 0 is the same number, so the answer is 0. So this is very good that you see on the board. If I am facing a quadratic equation, I might have two different solutions. I might have one single solution, or I might have no solutions at all. So these are the typical things that you need to remember. It might happen for a quadratic equation. Yes? In a linear equation, we almost all the time had one single solution. Is that clear? Okay. So, for the case that b is equal to 0, the solution is actually very simple. It's a little bit more work than this originally. Okay, what happens if c is equal to 0? I want to wait for you to listen from you, okay? If c is equal to 0, do you have a method to solve it? So it is not in. Let me bring it a little bit over. Okay. So that equation, consider that equation top there, but this time I want to put c equal to 0. Okay, so what happens? If c is equal to 0, then the equation that I will have only consists of two terms. One quadratic term and then one linear term equals to 0. So for example, if I give you x, if I give you a is 2, and if I give you b is 4, and I ask you to solve this, I hope that you agree with me that here it is not as easy as that one to make x alone, because I have different powers here, x squared and x. Which one you want to make it alone? Thus I want you to understand the previous method will not continue to work for this case, yes? Okay, so do you have any suggestions here what to do? Even if you are able to guess one answer, guess is not good. We want to convince ourselves that these are the only numbers that will satisfy if I replace them with x, for x. Yes?
Well, if you move 4x to the other side and divide both sides by x.
No, divide by x is not acceptable that much. The reason is that, of course, you have to be careful. If you are careful, that's okay. But if you're not careful, but this is dangerous. Why? Because when you move to the, what is, actually, this is a good point. When Oscar is mentioning, okay, move this to the other side. So far, so good. When I move this to the other side, I have to make it negative, I did it. And Oscar is saying that, okay, let us divide everything by x. If I divide this by x, what happens? One of these x's and one of these x's are cancelled, so I will get 2x. And one of these x's and this x are cancelled, I get minus 2. And then you don't have any problem solving this, yes? Because this is a first degree equation, you want to make x alone. You divide by 2 and you get minus 2. Actually, this is not wrong, by the way. Let us check. Minus 2 is really a solution. Why? Let us calculate the left-hand side. Instead of x, I put minus 2. Okay, but let me calculate. Minus 2 to power 2, positive 4. Positive 4 times 2, positive 8. 4 times negative 2, negative 8, and that is equal to 0. And this is indeed true. It's not false. But can I claim that I solved the equation?
No.
Why?
Because there could be more.
There could be more, and there is one more that you can also guess. Can you guess another solution for this equation? Yes?
2.
No, 2 doesn't work.
Minus 1.
No, 2 times 2 to the power of 2 is 8, plus 4 times 2 is plus 8. It is not working. 1 doesn't work.
No,
2 times 1 to the power 2, 2 plus 4 is 6, yes?
Positive 2?
Pardon?
Positive 2?
Positive 2 doesn't work. I just told here. Yes?
0.
0. 0 is another solution, because if I replace x with 0, this becomes 0 and 0. So 0 is a solution, but why I am missing it in this apparently logical way of doing, I want you to understand. The reason is that I am only allowed to divide an equality by a number so that it is guaranteed that number is not 0. So when you say, Oscar, that I divide both sides by x, implicitly you are assuming that x is not 0. And it is not surprising you are not finding the 0 answer. Is that understandable? So be careful. This is not valid. Because I don't know x yet, because my goal is to find x. So I don't know if x is 0 or not. But when I want to divide something by x, I have to be sure that this x is not 0, which I don't have it now, because I don't know the solution. So this method gives you only the non-zero solution, and that is correct, because when we checked that, it was working. It means that if x is not 0, then what is x? X is minus 2, if x is not 0. But don't do that, because I want to... this is not wrong, I want you to understand this method will always give you a non-zero solution, which is definitely true, but is not the whole story. What I want you to do is to use factorization, yes? And why factorization works, it is immediately clear now. Can I factor? For the time being, don't consider zero. If I have given you this in factorization part, I think it's a very simple factorization for you. What's that? What can I factor out here? More than x.
2x.
I can factor 2x, yes? And then what is left from here? 1x. What is left from here is positive 2. And now let us take this one away. This is equal to 0. And this number 0 is extremely important. Only 0 will work. Yes? Now, what I'm saying is that I have a number I don't know, because x I don't know. I have another number I don't know, because x I don't know. But I know something. I know the product of these two unknowns has to be 0 somehow. So when the product of two numbers is 0, there is only one. There is either this number is 0 or that number is 0. There are no other options. Yes? So that is why from here, this is called the zero product rule. Yes? The zero product rule. Yes? What does it mean? It means that A times B is 0. I am allowed to conclude that A is 0 or B is 0. This is called the zero product rule. Yes? So now, this is playing the role of A, this is playing the role of B, the product is 0. So this means that either the first number is 0 or the second number is 0. Is there a third alternative? Is there anything else that I haven't considered? No. If this is not 0 and this is not 0, then the product is definitely not 0. So I want you to understand this is actually equivalent to this. A dot B is equal to 0 if and only if at least one of them is 0. So then it means that, look here, what type of equation I am facing? I am facing a first degree equation and I know how to solve it by making x alone. Divide x both sides by 2, this x gives me 0. And that was the solution which we were missing. Or, I want to make x alone. Why? Because this is a first degree equation, I have to use the previous methods. So that is the solution. And I hope that this is important to understand that we really solve the problem, not guess. Yes? You might say that, okay, how should I know there are no other solutions? I would say there are no other solutions because if x is not 0, 2x is not 0. If x is not equal to minus 2, x plus 2 is not 0. And if I have two non-zero numbers, it is not possible to have the product to be 0. So these are the only solutions. Yes? So you see that in the case that C is equal to 0, the best way to do it is factor it out and use the zero product rule. What is the content of this zero product rule? It tells you that the product of two numbers is 0 if and only if at least one of them is 0. Is that clear? Yes? And you see that there is nothing much I can say here. Even if I give you this, for example, let me solve this one. 5x squared is equal to 9x. I want to solve this equation. Again, it is tempting to divide everything by x, and you get one answer right, that is for sure, but you will miss one. And so this is not the complete solution. So I would say that this is a quadratic equation where the constant term is missing because I do not have this constant term. But the point is that one of them is on the other side. It is a little bit different from first degree equations. In first degree equations, I put x on the one hand and the other ones on the other hand. But here you have to move everything to one side. So the first thing that I do, let me change my color here, and this is the solution. I will take it to the left. Then what should I do? Can you tell me if you understood this part? Yes?
You put either 9x is equal to 0 or 5.
No, it is not yet. It's not a product. The zero product rule. It does not work if this is subtraction. If someone tells me a plus b is 0, be careful. I am not allowed to conclude that this one is 0 or this one is 0. This is wrong. Yes? Yes?
Then you factor x.
So I factor x out. Yes, that's the correct thing. So I factor x out, then it becomes 5x, and then it becomes minus 9. And now this is the product of how many numbers? 2 numbers. That is the product of 2 numbers. So either the first one is 0, which actually I don't need to do anything, it's already solved. Or the second one is 0, yes? And then it means that I move the other one. Now this I can move 9 to the other side. Because this is a first degree equation, I solve it using the method that I have already learned about these equations. So I move this to the other side. And then this x becomes what? 9 over 5. So there are 2 answers for this. One of them is 0 and one of them is 9 over 5. Yes? Be careful, this only works for the case. If I give you the product of 2 numbers is 1, you are not allowed to conclude one of them is 1, one of them is minus 1. Oh, sorry, one of them is 1, the other one is also 1. No, it doesn't work, yes? Because 2 times 1 over 2 is possible. I don't know, 2/3 over 3 over 2 is possible. You see, all the products are 1. So you cannot say something about A and B if the product of A and B is 1 or any other numbers, any number other than 0. The only property, this is the property of 0. Okay? Okay, now we are ready to actually tackle the general problem. So, yes, do you have questions?
Is this method for this particular, like, no constant case?
Yes.
Is solving it this way faster than if we would use the general
Yes.
method?
Yeah. So even if I want to solve it, even though I know the general method, I prefer to do it in this way. That's why I'm telling it. Otherwise, of course, you learn one method to solve all of them. But I don't recommend that. I want you to learn this particular case in which B is 0 and this particular case in which C is 0 in this way.
And same goes for...
And then we go for the general case that I want to talk about, okay? Okay, now the question is that what happens if none of these are 0? Then it becomes actually a little bit non-trivial and harder, especially if I make bad numbers for you, yes? So the point is that how we can solve these problems when A is not 0, B and C are also not 0. Okay, so let me just clean the board and then try to see what we can do. So because I want to follow the book, so something that's also good to know is, so I want to consider the case in which A is not 0, but it is equal to 1, and B and C are non-zero. Okay. This I want you to see this presentation, but I really don't want to force you to learn this for the time being. But for example, let me give you a simple question. X squared plus 5x plus 6 is equal to 0. So you see, if I ask you what is the value of A, the value of A is 1 in this case, the value of B is 5, and the value of C is 6. Yes? The reason that I want you to see this, because I want to teach you a little bit about factoring these kind of polynomials, which is important to know. It doesn't mean that you have to learn it in this way, because there will be one formula that I will give to you, and then this will be in the formula sheet. Whenever you want to solve any kind of quadratic equations, you read A, B, and C from the problem and put them in the formula. It will give you the correct answer. Yes? But for the time being, let us not jump immediately to that formula. Take this as an excuse to learn something more about factorization. My question is that, can you factorize this? The problem is not factorization. So don't look at the problem, just look at the problem right here. It's a polynomial, and I want to factorize it. What is the meaning of this question? I want you to write an expression which is equal to this expression, but that new expression is in the product form. Let me ask you again, yes?
You could flip the middle term.
How?
So you could do x squared plus 2x plus 3x plus 6. Then you could factor out the x in the
How did you know that?
I did this before.
Okay, so that is possible. That's one way. I don't know. What's your point?
Well, I just x plus 2 times x plus 3.
Yeah, that's just also working, as you just guessed. Okay, so what he is mentioning is quite good. I didn't want to actually go through that, but that's one way. Let us at least see that on the board. Yes. So what he is mentioning is that it needs a little bit of experience. So instead of 5x, we can write 2x plus 3x. No doubt about it, yes? Because 2x plus 3x comes back to 5x. But this is the only decomposition that will work, as I will mention. But I can write 5x in infinitely many ways. I can write it 1x plus 4x. I can write it 7x minus 2x. Why on earth I have chosen this? The reason is that if you look ahead of you, then you can use grouping. You take these two, we talked about grouping before, yes? Between these two, I can factor an x out. It becomes x plus 2. Between these two, I can factor a 3 out. This becomes again x plus 2. And this is called a successful grouping because a new common factor emerges. So that I can factor it out. Yes? So now, if you don't believe, if you multiply this by that and simplify, you will get this back. So this one is equal to this, and this is factorized for because that's a product. Yes? That is one way of doing it, and I don't want to disturb you by these methods, but I want you to see them at least once in the lesson. Okay, another one that I usually myself use is this. Let me just consider this. X plus A multiplied by x plus b for the time being. What happens if I multiply these two? X times x becomes x squared, x times b becomes bx, and then a times x becomes ax, and then finally ab. And then if you don't mind, let me just write it in this form. Instead of writing bx plus ax, let me just factor x out from here and write it in this form. Yes? So you see, you can compare this with this one. If I can guess two numbers so that a plus b is 5, and then AB is 6, then I am done. Yes? So you see, when I want to factorize this, it is sometimes not easy to guess. But if it is easy to guess, I always use this method to factorize it. I ask myself, I need two numbers. So sorry, I made a little bit of confusion. Don't get confused with this one. Let me write alpha and beta. I shouldn't use the same symbol for two different things, yes? I was confusing you, sorry. Yes, now like this. So now alpha plus beta, alpha, beta. Can you guess two numbers so that the sum of those numbers is 5 and the product of those numbers is 6? This is based on your guesswork. There is no guarantee we can guess if the numbers are hard. But if the numbers are fairly simple and straightforward, guessing is not hard. So if I want to factorize this, I ask myself, can I find two numbers so that the sum is positive 5 and the product is 6? If the answer to this question is yes, then you immediately can factorize it. How? You open two pairs of brackets, put x here and there, and then guess those two numbers. I hope that you can immediately guess those numbers whose product is 6 and the sum is 5. What are those numbers? 2 and 3. So you put positive 2 in one of them, positive 3 in the other one, and then you get your factorized form, which was the same thing here. Okay, but now I will give you a little bit more practice in this, even though I told you that you don't need to learn it. But from my perspective, it is really important to learn it. Okay? It's not probably given in the book, but it is important to learn this method. Now that you know the factorization using two methods, so you see this method is a little, you have to be a little bit creative. But here you just based on guess. If the numbers are big, I myself cannot guess. So I have to learn a way to solve it. Okay, now can you tell me what are the answers to this? Now that you know the factorization, either in this way or in that way, you can immediately solve the problem. Why? Because instead of this, you put this, and then it becomes x plus 2 times x plus 3 is equal to 0. And then this number multiplied by that number is 0. Then the zero product rule tells you that either the first one is 0 or the second one is 0. Yes? But if the first one is 0, this tells you that x is negative 2. And if the second one is 0, this tells you that this is minus 3. So that's very interesting. So if I ask you solve this equation, if you can factorize it quickly, you don't have any problems. You really don't need to learn about that fairly complicated formula. You just write it in factorized form and use the zero product rule to find the answers. Is that clear? Yes or no? Let me give you one more example of this type. I told you, you really don't need to bother about this if you don't like to, but I really recommend you to learn. So let me just give you another one. X squared plus 12x plus 10 equals to 0. So you see, remember, let me emphasize here, I am always considering the cases in which a is 1. A is 1. And I ask you to solve this quadratic equation. The numbers are fairly simple. Sorry, this is not 10, this is 20, sorry. By the way, it doesn't mean 10 is wrong, or we cannot solve it for 10. Yes, we can, but it becomes more complicated. Okay, so the first thing comes to mind, if I really want to do it myself at this level, I see that this is a quadratic equation. Why? Because a second power appears. And I know this is a complete quadratic equation because b is not 0, c is not 0. And I know that this is one of the special cases that a is 1. Before doing anything, I will try to solve it using factorization. Okay, if possible. If the numbers are big, I myself cannot do that. Let me emphasize it again. So what I do, I put two x's here and there. And I ask myself, can I guess reasonably in a short time? If you want to spend hours to guess, that's not useful. You have to go to the formula. So here, I want to guess that I need two numbers whose sum is s and the product is p, considering, you see, I'm considering the signs as well. Can you guess those numbers? It's fairly simple. Yes?
10 and 2.
10 and 2, yes? The sum is 12, the product is 20. You put 10 in one of them, it depends which one you prefer, 2 in the other one. And then this is equal to 0. Now the solution is very simple. The product is 0, either this one is 0 or this one is 0. If this one is 0, it's a first degree equation. I don't have any problems with that. I move x, I want to make x alone, or so the solutions of this equation are only two. One of them is -10, one of them is -2. Understandable? Let me give you one more example. Actually, this is good to practice a little bit about factorization. So let us see how you think about this problem. X squared minus x minus 6 equals to 0. So let us repeat. At this level, when I want to solve this, I see this is a quadratic equation because x squared appears. And then b is not 0, c is not 0, and a is equal to 1. So instead of jumping immediately to the formula, I will try to solve it using factorization if possible. Yes? If it is possible, because sometimes it is not. So I open two pairs of brackets, put one x here, one x there, equals to 0. Then I ask myself, can I guess two numbers whose sum is this? But what is this?
-1.
Yeah, it is -1, which is not written. Yes? And the product is -6. Can you guess those numbers? Yes?
-3 and +2.
-3 and +2. Yes? -3 and +2. Why is that? -3 plus 2 is really -1. If I add them up, and if I multiply them, it is -6. Those numbers are correct. Yes? And then immediately you use the zero product rule, telling that x minus 3 is 0, or x plus 2 is 0. This is a first degree equation. I want to make x alone. I move 3 to the other side. Or x is -2. Yes? Okay. But what happens if I cannot guess? Or what happens if this a is not equal to 1? Yes? In my videos I have talked quite a lot about these things, but I don't want to concern you about those. But I want you to learn this. So whenever you have you have 1 here, this is faster than going through the formula that I want to teach you now. But this formula will always work. That's a good point. Okay, now my question is that, let us go back to one of these questions. Solve this question without factorization this time, because this will teach you. I don't want to just give you the formula without understanding, yes? I want you to understand why the formula works and how we can find the formula. So, okay, so what we do, is actually, if you don't mind, let us go back to the same equation that we solved using factorization. But this time, I want to hear from you what other strategies you might have if I want to solve this equation. even stronger than factorization, yes? Because I hope that you agree, factorization somehow is based on the guess. Even in the Hia's method, she was able to guess that we have to break 5x to 2x plus 3x. So it's based on a guess. For example, if I give you this horrible equation, this is not working at all. So this is also a quadratic equation, but in this case, a is square root of 2, b is this strange number, and c is this one. There is no way even for me to guess, to factorize this by guessing. So it means that I really have to have a systematic method which is not silent even for the complicated problems. But that is the goal. Okay? So this factorization is somehow based on educated guess because the numbers were fairly simple. But if the numbers are complicated, we cannot guess the numbers. Can you guess two numbers whose sum is this, and the product is, for example, 5 divided by square root of 2 or whatever? Because making this 1 is not hard. I can divide everything by this, and this becomes 1. This becomes even more complicated. Can you guess two numbers whose sum is that complicated number and the product is 5 divided by square root of 2? No. It's not reasonable to do it in that way. But the method that we want to develop here will also be able to solve those equations. And that is a powerful method. Now, can you tell me what other ideas you might have? Let me put the equation in front of you again. I want to hear from you. Do you have any other ideas rather than, except actually factorization, so that we can solve the problem? So if you don't mind, let me change this a little bit because this number is odd number. You might face a little bit of problem. Let me at least for the beginning, I start with an even number. So let me write it like this. Yeah, let me make it like this. I will come back to this. I don't mean this is not possible, but I don't want to face with fractions and things like that. Let us think about this problem. By the way, can you solve this problem using factorization? So, can you guess the numbers? I need two numbers whose sum is positive 4 and the product is negative 5. Can you guess those numbers?
No.
Yes, Ali?
-1 and +5.
-1 and +5. -1 and +5. If I add them, it becomes positive 4. If I multiply them, it becomes negative 5. So it is possible. Yes? But now, forget about factorization. Can you tell me another thing that we can do? I don't expect, of course, you to tell me, but if you say you are really smart, yes? How can I do that? I can give you a hint. Even though this seems a little bit strange, I move 5 to the other side. Only 5. Okay? And I want to add one number to both sides. But what number? I give you the number, but tell me why. I add 4. Why 4? Why 4 was good? Yes, Ali?
So you can use squaring rule on the left
A
side.
squaring rule. So this forms a squaring pattern. That's what I'm saying, that you have to detect, you train your eyes to detect these patterns immediately. So there is only one number that I can add to make the left-hand side a squaring pattern, and that's 4. Okay? Why? Can you see that? Can you factorize it now? X plus 2 to the power of 2. Do you agree? The first one squared is x squared. 2 times the first one times the second one is 4x. And the second one squared is this one. And then 5 plus 4 is what? 9. But I hope that you agree with me, this method is very powerful now and it is working. Why it is working? Because there is a black box that I don't know, because I don't know x, but I know something. Whatever is inside here, square it, it is 9. So what is x plus 2 then? What is in the box that I don't know? If I tell you box to the power of 2 is 9, what is the number in the box? What is the number in the box? 2 numbers, 3 or minus 3. So this means that from here, I can continue and write x plus 2 is 3, or x plus 2 is negative 3. And then if x plus 2 is 3, I don't have any problem solving this. I just move it to the other side, because the first degree equation, x is 1. And the same story here. So what's that? Minus 5. So these are the numbers that probably we were not able to immediately guess in the beginning. By the way, the numbers that we are getting here, don't get confused, are exactly opposite to the numbers Ali mentioned. It doesn't mean Ali made a mistake. No, it was right. The numbers are opposite to that. The roots are opposite to the numbers that you guess. Because if you factorize, what do you factorize? You factorize it to x minus 1 and x plus 5 equals to 0. Then you will say that this is 0 or this is 0. If this is 0, you have to move it to the other side. It becomes positive 1. And if this is 0, you move it to the other side. It becomes negative 5. Okay? So, I would say that this method, if it comes to my mind, is faster. I don't know. That is not also very long. But I myself prefer to factorize whenever the numbers are friendly and small enough. Yes? Okay, any questions here? So this method is called completing the square method. Completing the square. So if I want, I can put a hyphen here. Completing the square method. And it's a good name, because I managed to complete the square by adding some nice number to it. Yes, is that clear? So I want you to learn this. I hope that you agree with me. This is a general method. Of course, I will practice on this, but before doing that, let me go back and solve this one. Yes, by completing the square method. You see, let me just review a little bit. The equation that I gave to you is not following the squaring pattern. Because for a squaring pattern, I need to have 4. Unfortunately, I have minus 5. But that is not an obstacle. I move 5 to the other side, and then I add the number to make the square complete. And then I can solve the problem. Okay, so let me give you more examples. So let me give you this equation. Before going to that, let me give you an even one and wait for you, yes? So I give you x squared, and then I will give you 6x minus 7 equals to 0. I don't want you to use factorization. Of course, if you are interested, I think it is good to solve it in both ways. Each one of them is helpful to learn. But I want to wait a little bit for you. My concern is the completing the square method. Solve that equation using this completing the square method. I pause recording the video for 5 minutes. 5 minutes is too much. 3 minutes is enough. Okay? Okay, could you solve it? Yeah? Yes. So, if you don't mind, let us first use this method and then go back to this method. And then you can compare which one is more suitable. Okay, so, but this completing the square is completely generic. I will give you some examples that factorization doesn't work that easily, but still this method will work, okay? So here, what we do, completing the square. So, is this in this form a complete square pattern? The answer is no. Yes, because I don't want to have -7. So what I do, I move -7 to the other side. It becomes +7. Yes, but I want to make the complete square here. So I need to add a number to make the left-hand side a squaring pattern. What that number is? Yes?
9.
9. So I add 9 to both sides. X squared plus 6x, yes, plus 6x plus 9. On the right-hand side, I also have add to 9 to both sides. And then immediately, hopefully, you realize this is a good pattern, a squaring pattern. And the right-hand side becomes 16. And then there are two options. What is x plus 3? There are two possibilities. Either +4 or -4. And if this is the case, x is 1. Or if that's the case, x is -7. These are the answers. Yes? But if I want to use factorization, I don't need to move it to the other side. In contrary, I have to keep everything on the one side. So then, if it is possible, I have to open two pairs of brackets, put it equal to 0, ask myself, I need two numbers whose sum is this, and the product is this. And what are those numbers, if possible to guess? I need two numbers whose sum is 6, the product is -7. I think it's better to start from the product. If you want to make the product 7, there are not that many options. 1 and 7 are involved, yes? But you need to fine-tune the signs, if possible. So which one should be positive? The positive one should be bigger. The negative one should be the smaller one. So I hope that you agree with me. One of them is 7. The other one is -1. Always double check. Add these two numbers. Is it really +6? Yes. Multiply them. Is it really -7? Yes. Yes? So you see, it is faster. And now either this one is 0 or that one is 0. This means that x is -7 or that means that x is +1. And these answers are exactly those answers we got from completing a square. Yes? Okay, now let me give you another question so that you can feel really. So in these cases, you might say that, okay, factorization method is superior to this one. But yes, if it is going to consider about the speed, yes, if I can guess, that is easier. But sometimes we cannot guess. I haven't forgotten, I have to solve that equation for you again. But before doing that, let me give you another one. Okay, let me just solve this one for you first, before going to this. So x squared plus 5x plus 6. This is a little bit preparing you for this. If I want to use it, factorization, we did it before. Let us just do the second method. What I have to do, I have to move 6 to the other side. Okay, now that is my question for you. Can you guess what is the suitable number? In these cases, guessing 9 was simple. So what is that number that I have to add to the others, to both sides? It's not a friendly number as 9 in this case.
6.25.
6.25, you mean this? Yes. But how did you come to that number?
Well, since we're supposed to add something, 5x is the AB part of the squaring pattern.
Yes.
So since we're already multiplying it by, 2AB, since we're already multiplying it by 2.
So we
then,
divide by 2. That's
yeah.
correct. Yeah. So this is the trick. This number divided by 2 squared is the number that you are supposed to add. So even without being aware of that, you did the same thing here. Yes. You divided 6 by 2 and square it. 6 divided by 2 is 3. So the power of 2 is 9. But the problem was easy, so you didn't even think about this. But this is the way that you realize it actually. In this case, so you remember, this pattern is always and always the case. So you take this number divided by 2 and square it. That is the number that you have to add. This number is 25 over 4. Which, as here mentioned, it is 625, but let us keep it in fraction form. So the number that we have to add is this number divided by 2 and then totally squared. So that trick you need to remember. I don't know, either you have to discover it all over again, but this is the trick that will work. This becomes x squared plus 5x. Of course, you don't need to memorize, you need to understand. If you don't understand why, you can ask me again. So I just add this number, this magic number to both sides, yes? If I want to explain why this is a good, so I would say that this power of 2x plus 5 over 2. If you don't believe, let us check. The first one squared is this one. And that's exactly the reason for this 2. 2 times the first one, which becomes 2x, multiplied by the second one. And that is intentionally, I put this 2 in the denominator so that this and that will be cancelled, and 5x is left. And that's 5x. And then it is inevitable. If I chose this, I have to have 25 over 4. When I add 25 over 4 to this side, I have to add to that one as well. But then, you need to do this in your head or using the calculator, whatever, but in fraction form. So minus 6 is minus 24 over 4. And this is plus 25 over 4. And it becomes 1 over 4. This becomes 1 over 4. And now you really understand that factorization method was superior here. At least it was faster. Yes? Here I have to work with fractions and things like that. This is not finished yet. Because I'm asking a number whose second power is 1/4. So this becomes x plus 5 over 2 is 1 over 2. Or x plus 5 over 2 is negative 1 over 2. So let us do this in our head, yes? 1 over 2, I move 5 over 2 to the other side, it becomes negative 5 over 2. 1 over 2, negative 5 over 2 is minus 4 over 2, which is minus 2. Or, if you calculate this, it becomes minus 3. Now you can judge for yourself. You see, this method is the completing the square method. That method was just factorization method. And as you see, the answers are exactly the same. But the point, as I told you, is not because that we have to learn this. Because this is the general way to do these things. I will give you one more example and then I will stop. We'll continue tomorrow. One method that I want you to understand that really completing the square sometimes is superior to the other methods. And this is the example that I want to tell you. And I want you to solve it. Okay? I want to solve it together. Okay, so this question I want you to solve. We want to solve. So let me write x squared plus this. This is the last example for today, but please listen because this is important. I know might be you're tired, but try to listen to this, okay? Can you solve this problem using factorization? If the answer to this is yes, you need to be able to guess two numbers so that the sum is positive 4 and the product is negative 7. I hope that you agree with me, guessing those numbers are not easy at all. Yes? Can you guess two numbers whose sum is 4 and the product is negative 7? Apparently it is not in our head, yes? So that is the reason that we have to learn the completing a square method. Because you might say that, okay, what the numbers are, we will see in a moment what the numbers are, but it is not easy to guess at all. But let us see that if the squaring method will work. Okay? Let us solve it using a squaring method. Everyone, just a few moments and then we are done. So what is the first step to solve this? So you see, if I see this equation, immediately I try to factorize it. But immediately I also realize it is not possible for me to guess, so I ignore that. Then I go to the method of completing the square. So how? I write x squared plus 4x, I move minus 7 to the other side, it becomes 7. I intentionally gave you a simple number here. What is the number that we have to add here? 4, yes? So because this number divided by 2, squared. So it is x squared plus 4x plus 4. And then let me add 4 to the other side, it becomes 11. And now you realize why it was not easy to guess. This becomes the pattern, but this becomes 11. So can you tell me what is x plus 2? X plus 2 is a number so that when I square it, it becomes 11. So what that number is? What is it? Either square root of 11 or minus square root of 11. Now I am looking for x. I have to make x alone, so I move 2 to the other side. So x becomes minus 2 plus square root of 11. This is one root. I was not able to guess this number out of my head, yes? And then the other number, x, I move 2 to the other side, it becomes this. So you see that even though I was not able to guess anything, but still I was able to find the answers. And the answers are so odd that you shouldn't expect that I was able to guess. Okay, now can you tell me what are those numbers that we were supposed to guess? We couldn't. Opposite to these numbers. Opposite to this is 2 minus the square root of 11. Opposite to this is positive 2 plus the square root of 11. These are your magic numbers. If you could guess these two strange numbers from the beginning, you could also use factorization method. Let me check. Is the sum of these two numbers, what is the sum of this number and that number? If I add them, this is gone, this becomes 4. So the sum of these numbers is indeed 4. But what is the product of these numbers? Let us multiply. What pattern you detect now?
Conjugate.
The conjugate pattern. So the answer becomes the first one squared minus the second one squared. The first one squared is 4. The second one squared is 11. And what is the answer? Minus 7. So the numbers whose sum is 4 and the product of -7, they are these numbers. But we were not able to guess them. Do you agree with me? So this is why solving this using the squaring method, completing the square method, is more practical for us. Yes? Okay. The lesson is not completely finished. I wanted to give you a feeling about the problems here, but there's one more step. And hopefully you can guess what is the next step. The next step is that what happens if this coefficient is not 1. Because in that case, we want to justify this method a little bit. And then the whole package will be finished and I will give you time to practice. Any questions? So let me just again officially mention, this is chapter 3. Chapter 2 is finished, and it will be, when we're done with here, we combine these two chapters in one exam, okay? And I will write on this Google Classroom that this is the starting of chapter 3. Yes? Questions? You have still 20 minutes left. If I were you, I will take a 5 minutes break and then I don't lose that 15 minutes, but that's up to you. Thank you.